G'day, I'm Jacob from Make Science Fun. Welcome to my science laboratory. Thanks for joining us today. This is my assistant Sam. Hi Sam. Hey! Ow! And my robot helper. Here in this Lego lab, we're going to do real experiments with real chemicals right before your eyes. We hope you enjoy, and we hope that you'll learn some science. Giant measuring cylinder here, and we've got water in it. How about you put a bit of detergent in? So squeeze some detergent in. Awesome. Beautiful. And now you can give it a bit of a stir.
Mix it.
Good. Give it a stir. Spin.
Bubbles.
Stir. Now I'm going to squirt in some universal indicator.
Wow. What colour is it now? Orange.
Okay, now I'm going to add a base. Now this base is sodium hydroxide. Let's see what happens. The nitrogen.
Oh!
What colour is it going, Sam?
Black.
Black?
Yeah.
Or?
Blacky green.
I'm going to put in some dry ice now.
Can I put some dry ice in? It's bubbling.
Even more bubbles. So Sam, the dry ice is solid carbon dioxide. It's got a temperature of minus 80 degrees Celsius. When it hits the water, it sublimates. It goes straight from being a solid to a gas. That gas produces the bubbles we're seeing. The white smoke, well, it's not really smoke. It's because the cold temperature causes the water to condensate and forms like cloud-like material. It's like a fog. Bubbles water. Alright, well thanks for joining us in today's episode. Please feel free to subscribe for more. Send in your comments and your likes, and Sammy and I will see you.
Ow!
Bye!
Bye-bye. See you later, alligator.
I'm Jacob from Make Science Fun. Thanks for joining us today. Now, unfortunately, I've been nominated to do the Ice Challenge. I'd like to nominate Jaden Costa, there's your shout out, and Stilly, everybody's favourite science teacher. Bill, you going first? Yup. Oh, that's freezing! Now, although Lego Man feels very cold and he's shivering, there's no lasting damage. In fact, shivering tightens the skin and shakes the muscles. It's a process that conserves and generates heat. Okay, Ben, your turn. Ah! That's not ice water! Ice water? Oh no! I thought we were using liquid nitrogen! Our Lego Man had a serious problem. The liquid nitrogen has a temperature of minus 196 degrees Celsius, well below the glass transition temperature of acrylonitrile butadiene styrene, from which Lego Man is made. Instead of being plasticky, Lego Man was now hard and brittle. Let's help him up and get him to a warm shower. Oops, my arms! Oh no, quick, let's split. Achoo! Now that was some ice challenge. Whoa. Well, Thanks for joining me in this episode. I look forward to some more science fun with you soon. That's how I make science fun. G'day, I'm Jacob from Make Science Fun. Thanks for joining me today in this episode. Today, I'm going to tell you the sad story about Lego Man. Now, Lego Man decided to cook some baked beans. And so, he followed the directions on the can, which said, open can and stand in boiling water for 5 minutes. And unfortunately, that's exactly what he did. First, he opened the can. And then, he stood in the boiling water. Now, as we know, water boils at 100 degrees Celsius, which certainly got Lego Man hot under the collar, but that was about all. However, as time ticked by, the water soon boiled away, and without any water, the temperature of the pan rose steadily from 100 degrees to 230 degrees Celsius. Now Lego Man had a problem, for he was made from acrylonitrile butadiene styrene, which melts at 230 degrees Celsius. He slowly underwent a physical change and melted into a puddle of plastic in the pan. Although this was quite serious, it was not necessarily the end of Lego Man. For if someone had shipped this pool of plastic off to the Lego factory in Denmark, they could have remelted him, fed him into a moulding machine and brought him back to life. However, this was not to be. Once he had fully melted, the temperature of the pan started rising again. When it had risen to 466 degrees Celsius, which happens to be the self-ignition temperature of acrylonitrile butadiene styrene, poor Lego Man burst into flames. And as we know, combustion is a chemical reaction and very, very difficult to reverse. So, goodbye Lego Man, goodbye, it was nice to know you. G'day, Jacob from Make Science Fun here. Thanks for joining me today. I'm feeling a bit strange today. All hard and plasticky and a bit stiff. Anyway, today we're going to compare the flammability of air to the flammability of hydrogen. So I'll just turn Mr. Bunsen burner on. Ooh, got a nice blue flame. It's a bit like a jet engine. Now, air contains about 78% nitrogen, 20% oxygen, and about 2% water and about 1% carbon dioxide. I'm going to use Mr. Robot to bring the balloon over the hot flame. And we'll see what air sounds like when it's in the balloon. Ah! This time, I've got a balloon full of hydrogen gas. Hydrogen gas is a flammable gas. It's lighter than air. Here we go. This has been Jacob from Make Science Fun. Please send in your comments, please subscribe, and I'll be seeing you next episode. Today we're going to have the flaming vortex of fire. We're going to have fire spiralling up the tube. Let's get Mr. Robot to turn on the machine. A little bit faster. Perfect. Okay, I'm going to put the flaming ball of fire in. Wow, look at that.
It's going up.
It's going up. Huh? Look at the smoke. It's going right here and in a tube. How good's that, Sam? It's nice, isn't it?
And it's spinning by itself.
Yeah, spinning. Well, the machine's spinning it, isn't it? Hey? Ooh. Whoa. It's sort of like a vortex, isn't it? Oh, getting hot. It's getting warm in here. Oh, wow. Look at that.
Funny.
Hey?
How does it do that?
That's magic, isn't it?
And it went out of there into on there.
It's almost touching the ceiling, isn't it?
Yeah.
Whoa! Look how big that flame is.
Yeah.
It's gigantic.
Yeah.
Hey? If you want to watch this flame vortex in full size with 3 different flame colours, just click on the link shown and we'll be seeing you soon. Thanks so much for joining us today. Bye bye.
See you later. Alligator. Really fun.
Hey, what are those things over there?
They look like eggs.
Yep, definitely eggs.
Let's grab them and bring them back to the lab. Load them up.
Let's go.
G'day, I'm Jacob from Make Science Fun. Thanks for joining us today. Hey, welcome to my laboratory.
Hi, I'm Mary. I'm a paleontologist from the Research Institute.
And this is Sam, my assistant. Hi, Sam.
Definitely some kind of egg. Strange, but somewhat familiar.
I'm going to try and crack one open.
This is just getting ridiculous.
You think that's ridiculous? I think we're going to need some other help. This is Marie, our chemist, from the Research Institute.
Hi.
Do you think you can help us open this up?
Well, like most eggs, the shell is probably composed of calcium carbonate. I think this hydrochloric acid should be able to dissolve the egg.
Wow, it's working. Look at the bubbles.
The shell's dissolved and now we just have this protein membrane.
It's pretty rubbery.
Yes, very elastic.
I'm going to try and bust it in.
Have another go.
I still can't break it. What are we going to do? Great idea, Mr. Robot. Let's try that.
Put the egg up there, Dad.
Thanks, Mr. Robot. Look, it's working, Sam. Mr. Robot is drilling a hole in the top of the egg.
Yep, perfect.
I'll just fill it up with hydrogen gas. When you ignite the gas, it should explode the egg open.
Okay, light me up. I'll just light the hole. Wow!
Baby dinosaur! Come back!
Looks like they haven't gone extinct after all. Let's explode a few more eggs and see if we can find another one. G'day, I'm Jacob from Make Science Fun. Thanks for joining us today. This is Marie, our chemist.
Hi.
Got my assistant Sam. Hi Sam. What are we doing today, Marie?
Today we're making magic mud, which is a non-Newtonian fluid.
Cool.
Just add some water to this cornflour
Sure.
and I'll mix it up. Perfect.
Mix it, mix it.
Now I'll just inject some of it onto the loudspeaker.
All right, Sam. Turn up the volume.
Ooh.
Higher frequency. Slightly lower. Oh!
Let's try some different colours.
Yellow, green, blue, white, red. All right, Sam. Turn up the volume. Oh, yes.
Ah, well done.
I love how the colours combine to form new colours.
Ooh, like a monster.
Oh, yes. That's what we call the oobleck dance. Wow. Ah! Let's go clean up.
Okay.
Oh, wow! Who's cleaned up this place? How awesome's that? Oh, Mr. Robot, did you drop that rubbish on the ground? I'm always picking up after you. Anyway, thanks for joining.
That's how I make science fun. Oh yeah, light travels in a straight line. I'm Jacob from Make Science Fun. Thanks for joining me today. In just a few seconds, Sam will join us as well. Hey!
I can move.
Today we're looking at how darker objects absorb more light and hence heat up faster. So we're going to have a bit of a race. I've got two identical steel balls. One's been painted black, the other one's still shiny silver. They're sitting on identical blocks of ice. The black one's clearly going faster than the silver one. However, it looks like the silver one, oh, that was a big jump. The black one's sinking in further than the silver one. And it looks a bit like a close race here. So the black one is on the back of the ice. The silver one is on the front of the ice cube. The silver one's about to land on the stump. It's neck and neck, but the black one's just a little bit ahead. Oh, whoa, oh! There goes the black one. The black one did absorb more heat. Now we're going to do them next to each other on the same block of ice. Oh, and it's neck and neck, but the black one's just a little bit ahead. They're so close though you could throw a rug over them. The black one's rolling out to the right. It looks a bit like a close race here. And the black one's about to roll out, and the black one's out. The silver one, oh, it's taking a fair while longer. And, oh, gone. Now I'll turn the heat lamp off, and we'll let the ice just melt naturally. And it's almost gone. Hi, Sam. Hey. Black objects do absorb more light than lighter objects. I'll see you guys soon. Thanks so much for joining me today. Bye.
G'day, I'm Jacob from Make Science Fun. Thanks for joining me. Today we're doing a volcanic chemical reaction. Woo! First I need some potassium permanganate, which acts as the oxidizer. Then I need to add the fuel, which is just some glycerol. Now we just wait. A bit of smoke, a bit of steam, oh, a little bit of lava, oh, a bit more smoke, a bit more smoke.
Oh, help! The lab's on fire! I'm on fire! Oh, goodbye, cruel world.
Sam, I'm your father. I think I can still hold a test tube. Yeah.
I love me, Dad.
Make science fun.
Stop that!
It's okay, Sam.
Stop that!
The seed must die before new life can sprout.
You're burning, Dad! I love you, Dad!
Sam, I'm back.
You're alive!
All better again. Yoo-hoo! Better than ever.
I like your new coat.
Ready to do science again, son. I need a new lab though. Woohoo! Check out this new lab. It's beautiful. It's clean. Oh, let's start with a decomposition reaction. I'm going to add some hydrogen peroxide to this measuring cylinder. Now just a little bit of manganese dioxide. Look at that, Sam. Bubbles. Oh, no, not my new lab. Oh, yuck. Oh, no. My brand new lab. I've wrecked it.
Hey, look at this!
Oh, I'm so stupid. Oh well, I'll have it cleaned up for next episode. Thanks for joining me today, and I'll see you guys soon.
Bye-bye.
Bye.